Maximum subarray. In this problem, we're given an integer array nums and we need to find the subarray with the largest sum and return its sum. So in example 1, we have an array called nums which has all these values, and if we scan through the entire array and we check each individual element and then check contiguous elements or elements that precede each other, eventually we're going to return a sum of 6, and that would be the result of this subarray. So 4, -1, -2, and 1. And if you go through this entire array and, like I said, review each individual element and review each potential subarray which you can form within this array, then the largest subarray that you're going to get is, or the subarray that offers the largest sum is going to be 4, -1, 2, and 1. So although this problem is classified as medium, we're going to make our lives much easier by solving it through dynamic programming. So basically what dynamic programming is, in a general term, it's breaking down a problem into subproblems, then solving those subproblems and maintaining the result in some form of memory, or in other words, storing the results of these subproblems. And then we're going to use the subresults of those subproblems to solve the bigger problem. Why are we going to use dynamic programming? That's because dynamic programming basically makes our code much more efficient. Our code will run faster for sure, and it will have a better space complexity as well. So I feel like the best way to understand dynamic programming is by actually solving another problem that we've already seen before, and that would be the climbing stairs problem. So in our older video, and I'll make sure I'll leave a link to that, we solved it through memoization and recursion, which are sort of related to dynamic programming. In this solution, I use dynamic programming to solve it instead of recursion and memoization, which I use in our video. So let's quickly go through this code so we can solve the maximum subarray problem. So just like our recursive solution, we're first going to check if the int n that they gave us is less than or equal to 3, and if that's the case, then we just need to return n. And like I said, I will link a video to this problem so you could understand the description better and what's required of us. Then what I did is I created a new int array. I called it climbing stairs cache, or CSE for short, which has a size of n+1. Why does it have a size of n+1? That's because in Java, indices start at 0. And then within this array, we're going to sort values from 0 all the way up to n. So including the 0, we're going to have to account for it. Our size of CSE is going to be n+1. Now, like I said, in dynamic programming, we break down a problem into subproblems or smaller problems, and we're going to use those subproblems to solve the bigger problem. So what am I doing here? In this array, I'm storing results of certain pre-assigned values, which we already know. We know that if n is equal to 0, then you can only climb 0 stairs. We know if n is equal to 1, then you can only climb 1 stair. 2 is 2, and 3 is 3. It's only when we get to 4 and above that we're going to need to look at an equation. So I'm storing the results of my subproblems, because remember I said we're going to store our results so we can use them to solve a bigger problem. I'm going to store the results of my smaller problems into this array, and then within this for loop I'm going to fill up the rest of the array for values of n larger than 3. So here we're going to loop starting at I equals to 4, because our array already contains the first 3 indices, 0, 1, 2, the first 4 indices, 0, 1, 2, 3. And we're going to make sure to only fill up the array with the correct size, nothing more, nothing less. And obviously we need to increment I after every iteration. Now just like the recursion, we're going to follow the same problem, or the same equation which we found. So the value we're going to store in position I equals to 4, or in other words, when the number of stairs we need to climb is 4, we're going to store CSE I-1, which is 4 minus 1, which is 3, plus CSE 4 minus 2, which is 2. And these values already exist in our array because we assigned them previously. We already know the answers to these. And so we found CSE at 4. And then when we increment, we can, if n is equal to 7, at I equals to 5, we know that CSE at 5 is going to be equal to CSE at 4 plus CS3 at 3. And we already calculated 4 from our first iteration and we stored it. And this loop goes on until this for loop terminates. And in the end, we just need to return the value of the last element in our array. So with that out the way now, we can actually come back to this problem and solve maximum subarray. So in this problem, like I said, well, besides the fact that we need to break it down into smaller subproblems and see which one is the largest value and the largest subarray. So there's actually many things we need to do, right? We need to check each individual element, because maybe we have a huge element like 17 that's larger than the result of all the other numbers added up, or any combination of numbers added up. Of course, they have to be next to each other within the array. We also need to check multiple subarrays, so we need to check -2 and 1, -2, 1, and -3, and then we check 1, -3, and etc, etc. There's a lot of subarrays. So first and foremost, what we're going to do is I'm going to assume that the very first number in our array is the maximum number. So int max equals to nums at 0. So I feel like it would be a bit difficult to explain how we're gonna solve this before I begin coding. So I'm gonna code, and as I code, I will explain what's going on. So similarly here, we could create an array to store our values, but that's really not needed, and we'll see why in a moment. So within this problem, we could create an array and store our results, but instead what we're gonna do is we're going to store our result in a variable instead, not an array, and we're going to update that variable if it meets a certain condition. So now what I'm going to do is I'm also going to create another int variable called current sum, and temporarily, or for the time being, I'm also going to assign it the first number in our array, but obviously we're going to change it. So now I'm going to iterate through our nums array. So for int I equals to 0, as long as I is less than nums.length I++. And then within this for loop, I'm actually going to update current sum to be current sum equals to math.max. So within our for loop, within each iteration, current sum is going to be the max value between the comparison of nums at I and current sum plus nums at I. So what am I doing here? I'm setting current sum to either be the current number which we're on, or our current sum plus the number which we're currently on. So if we take a look at example 1 once again, int max is nums at 0, so int max is equal to -2, and current sum is also equal to -2 initially. Then we're going to iterate through the elements in our array, and current sum is going to be equal to math.max. And I realized I made a mistake here. I need to set this to 1 because we already assigned values for 0, so there's no need to start at 0. Math.max nums at I, which is 1, which is also coincidentally 1, or current sum, which is -2, plus nums at I, which is once again 1. So -2 plus 1, that's -1. What's the maximum value between 1 and -1? That would be 1. So our current sum is now equal to 1. If you notice, what we did here is we checked if the current number which we're on is greater than current sum, where current sum could be the previous number that we were on, or the combination or the summation of a previous subarray. Now what we need to do is we need to compare current sum to max. So if current sum is greater than max, then obviously max is actually current sum, and all we need to do is return max. So let's submit our code and see if it worked. Okay, so I got the wrong answer here because I made a very small mistake that I didn't notice. Our if statement should be within our for loop. I'm not sure how I wrote it outside the for loop, but that's okay, small mistake. So let's submit our code again, and there we go. So that was the maximum subarray problem on LeetCode. That was also sort of an introduction to dynamic programming. We took a look at the climbing stair problem, which we previously solved recursively, and once again I will link a video to that in this video. So like I said, that was an introduction to dynamic programming. It's a coding method related to recursion, and it ensures that our code runs more efficiently and with a better space complexity. So I hope you found that video helpful, and thanks for watching.